Hey, calculus wizards, welcome back. So we're continuing on this chapter of limits, and today we're going to look at the properties of limits to start with. So when we are evaluating limits, obviously you can look at a graph. That's what we did in the last lesson. And today we're going to do them analytically. So when I'm doing them analytically, all I'm doing is just some plain old-fashioned algebra. But, you know, we're so sophisticated, we say we're using calculus. But really, we're just using algebra. So if I notice this first one, the limit of x, remember x is my domain value, is approaching some number. But here, I really just have a constant. So the y value doesn't change. In other words, if I were graphing y equals 5, it doesn't matter what x gets close to, y is still 5. So for this one, the limit is still just b. And so an example over here, again, doesn't matter what x is getting close to, this is really y equals 10, so the limit is still 10. Now notice here, now I have a variable in what I'm taking a limit of, and as x gets closer to c, this is really y equals x, is the function. And so obviously those are the same. If x is 7, y is 7. If x is 20, y is 20. So whatever value x approaches, so does y. So the limit as x approaches c of x is c. And so I have an example over here. Again, keep in mind this is really representing y equals x. And so if x is getting close to -1, then y is also getting close to -1, so the limit's -1. See how easy this is? And then on this last one, same thing. As x gets closer to c, then of course the x value approaches c, so this becomes c to the n, since I had that little exponent right there. And over here, as x gets closer to 4, then the limit approaches 4 cubed, or 64. Moving on. So some examples of properties is if I know the limit of f of x is some particular y value as x gets closer to c, then I can do a little bit of calculus, I suppose, although it's really algebra with this. And so here I notice I have some particular coefficient, and I can bring that out. So then I get b times the limit as x approaches c of f of x. But I already know that this is L. All of this is defined to be L, so this really is BL. And so I have an example over here. I can pull the 4 out in front, and then I have limit as x approaches c of f of x. And of course I know that all of this is really L, so this is 4L. If I have a limit of a sum, then it's equal to the sum of the limits, so I can separate these. Same with a difference, so adding works and so does subtracting, but I can separate them into their own individual limits. And then we look back up at the top and we say, hey, we already know this. This is L. Ooh, hey, we already know this. This is K. So this turns into L plus K. Same thing is true about product. I can separate them. Oh my gosh, this is so easy. I love doing calculus. What about you? So I can separate them. And again, I get super jazzed because I feel really smart that I'm doing calculus right now. And I go, hey, I know this, it's L. And hey, I know this, it's K. So this is L times K. And what do you suppose happens with the quotient? I bet you guessed it. I can separate them. And so when I do, I have the limit on top of f of x and the limit on bottom of g of x. So I get L over K. And of course, we have to make note, K cannot be 0. And then last but not least, this p of x just represents a polynomial. And so if we want to know what happens when x approaches c, well, we really just get the value of the polynomial at c. See you next video.